This is a short video on how to construct a box plot, also known as box and whiskers plot, from some data. Now, the important thing to know about the data is, number one, it has to be in order from smallest to largest or vice versa, but most people smallest to largest. The second thing you need to know is how many elements are we dealing with. In this list, 5, 6, 7, 8, 9, 10, 11, there's 12 elements, so I'm going to say n equals 12. Make this a little smaller. Alright, so the things we need to find out of 12 elements is the minimum, the maximum, the median, you should already know how to do, and then quartile 1 and quartile 3. Median is technically quartile 2, so you can also call this Q2 if you want, but most people just call it the median. Alright, so the easiest ones, of course, are the min and the max. So 2 is the minimum, 76 is the max. So this has quite a big range of 74 units. To find the median out of 12 elements, you could either do the kindergarten method, which is to count in until your two fingers hit the middle numbers, or you can take 12 and divide it by 2 and come up with 6. If you do this method, you have to understand that even numbers, remember, you have to take the 6 and the next one. If you rounded it, then you would just be taking one element. So we're going to take the 6th and 7th element. So 1, 2, 3, 4, 5, 6, and 7. So 15 and 19. Right down the middle of them would be where the median is. So if you add them together, that becomes 24. Correction. 34. Half of that would be 17. So the median is 17. Then what you do, change colors here, is when you split it down the middle like this, you're going to look at the left-hand side of the data as its own individual set and find the median of that. Well, there's 1, 2, 3, 4, 5, 6 elements here. So again, we're going to divide by 2 and take the two middle ones. So that would be 3 and 4. So it would be these two elements. So between them, if you add those together, you get 19, and half of that would be 9.5. So quartile 1 is the median of that left-hand side of 9.5. Alright, and then do the same thing on the right-hand side. From the 19 out, there are 1, 2, 3, 4, 5, 6 elements, and we're going to pick the middle two, in this case 29 and 31, which would be 50, 60. Half of that would be 30, so quartile 3 would be 30. Alright, so there's all the numbers that we need to deal with. So where you're going to start is on the far left over here. This is going to be your minimum, so call that 2. On the far right of our line, that's going to be your maximum, that's going to be 76. And you kind of have to divide this line up so that it can range from 2 to 76. So what I want to do is I want to be able to put all these numbers from 2 to 76. So I need to find the halfway point, and then that'll just give me some reference dashes so I can fit these numbers in it. So to find the halfway point between 76 and 2, to find the midpoint of a segment, all you have to do is add and divide by 2. So 76 plus 2, oops, and then divide 78 by 2. So halfway down here is 39. So this would be 39. Alright, and then halfway between 39 and 2 would be 39 plus 2, which is 41, divided by 2. It'll give us about 20 and a half. So right around here, if I back it off a little bit, would be about 20. And if I go the other direction, 76 plus 39, that's 115 divided by 2. That gives us about 57.5, about 58. So somewhere in here would be 58. Alright. So now all I have to do is, here's my min, here's my max. I'm going to do these in red. So I need to plot 9.5. Now 9.5 is about halfway between 2 and 20, so I'm going to mark it here, and I'll label it 9.5. Alright, the next one up is 17, which is just a little bit below 20, so 17 would go here. They're not perfect, but you get the idea of how things are going. This first quartile is very short. The median is 17. Going up to 30, which is, if this is 40, 30 would be halfway between. So here. So this is 30. And finally, of course, 76 way down there. So the rest of the box and whiskers, or box plot, is you draw a line for your first quartile, and you put a long line on that first quartile, long line on your median, and a long line on your third quartile, and you draw a little rectangle for these guys. What this rectangle represents is 50% of the information. 1/4 is here, 1/4 is there. This first quarter is rather squished together. The second quarter is a little bit further apart. And this one, let me make it a little thicker. This line here, I didn't do it. There we go. This line here, that's really thick, represents 25% of the information. So it's really spread out. And if you think about it, if you look at that last quartile, you're going from 35 to 45 all the way up to 76. And starting at 19. So a lot of the numbers are low, but then you have that really high one, so it makes that last quartile rather long. And that's what a box and whiskers plot looks like. I want to make it look a little prettier. That was too thick of a line. And that's all there is. One more thing before I leave this topic. That was with an even number of data points. So I want to talk about what would happen if you had an odd number of data points. So let's get rid of one of these values. Let's consider 76 an outlier. In other words, it made it so big that it was just kind of ridiculous. So if we get rid of him, then we're down to 11 elements. And the median, of course, is going to change for 11. So if you cut 11 in half, that becomes 5.5. If you round, it becomes a 6 element. So 1, 2, 3, 4, 5. 15 now is the median. Now, when you have an odd number and you find the median precisely like this, you cross it out. It's still part of your data set, but you don't want to look at it for the quartiles. So in this case, the quartiles would only have 13 down as their numbers, and there's an odd number of them, so 8 is the middle of those, so that'd be quartile 1. On the right-hand side, 29 is the middle of these, so that'll be quartile 3. And then the min here is 2, and the max is 45. I'm not going to draw the graph, but again, you know, you'd have your 2 way down here, your 45 way up here. You'd have to mark it off in such a way. 29 would be a little bit closer, so this would be like 29. 15 would be still down this way, about halfway, so this would be about 15. And then 8 would be about halfway here. So you can see, kind of in a way, that this box plot, if I can draw it really quickly, is a little bit longer by getting rid of that 76. So that's why I'm thinking of considering it an outlier. It makes our box a little bit bigger on the entire interval. So you have 25% of the information there, 25 in that little group, 25 in that bigger group, and then this one's about the same as the first two. So this is a better distributed box plot. All right.